Welcome to the Heart of Innovation and Exploration, CEST, the official civil engineering technical club of NIT Rourkela.
Is it audible? Yeah. Is it audible now? Welcome to the Heart of Innovation and Exploration, CEST, the official civil engineering technical club of NIT Rourkela. Here, we don't just teach theory, we ignite the flames of practicality and ingenuity, forging an unforgettable engineering experience. Our story began in the year 2012 when visionary postgraduates sowed the seeds of CEST. They understood that theoretical knowledge is not enough on its own. It's like a ship without a sail, directionless. Today, we have evolved into a powerhouse of talent ready to propel your engineering aspirations to new heights. Let's have a glance on our club through a short clip. Now, let's allow me to introduce the guiding light of our club, the executive body of CEST. They aren't just leaders, they are compass, ever ready to navigate us through the challenges and victories that come our way. So, let me introduce Mr. Bishop Prakash Bahinipati, Vice President of CEST Club. But our journey doesn't stop there. We present to you CIVI-NAR, an electrifying fusion of knowledge and connectivity. CIVI-NAR is not just an online webinar, it's a dynamic platform where the entire civil engineering community comes together. It's a stage where we dive deep into the most trailblazing topics of today's and tomorrow, led by experts who have mastered in their respective domains. As we carry forth our legacy, today's discussion delves deep into the intriguing topic, a digital based integrated approach for the preventive conservation of the cultural heritage buildings. Before we embark on this Atlantic journey, I would like to extend a warm welcome to our CEST Club advisor, Dr. Subhajit Mandal sir, who serves as an assistant professor in the Department of Civil Engineering in NIT Rourkela. Moving forward, we are graced by the presence of a luminary figure in the world of civil engineering, Professor Daniel V. Oliveira. His expertise transcends the ordinary, leaving an indelible mark in the realms of masonry, earthquake engineering, and preservation of cultural heritage. Professor Daniel's journey is nothing short of remarkable, with bachelor's, master's, and doctorates in civil engineering from esteemed universities. He has risen to become an associate professor at the Department of Civil Engineering at the University of Minho, Portugal. His research spans the experimental and numerical analysis of traditional and heritage masonry structures, earthquake engineering, repair, and strengthening of masonry, earthen construction, vernacular stone heritage, risk analysis, and durability. He has been involved in more than 40 research projects in the field of masonry funded on a competitive basis, carrying out coordination tasks or on 7 international and 5 national projects. In particular, he has been the principal investigator of the HeritageCare project and the UMinho local coordinator of the NIKER and OPHERA projects funded by European Commission. Now I invite the Vice President of Chess Club for his warm greetings.
Good afternoon, everyone. This is Bishwa Prakash, the Vice President of SES Club. It is with great pleasure and immense enthusiasm that I extend a warm welcome to all of you to the seminar series organized by the SES Club of NIT Rourkela. Today, we are honored to have Professor Daniel V. Oliveira with us with our distinguished guest lecturer, and we are thrilled to have Dr. Subhajit Mandal, the faculty advisor of our esteemed club, gracing this event. The seminar series is a platform where knowledge, expertise, and ideas converge, and we are delighted to see such a wonderful turnout. Your presence here today reflects your dedication to learning and your eagerness to engage in meaningful discussions. Professor Daniel, we are truly privileged to have you share your wealth of knowledge and experience with us. Your insights are sure to inspire and enlighten us, and we eagerly anticipate your lecture. To our esteemed audience, thank you for joining us. Your active participation and curiosity drive the success of the seminar series, and we look forward to your valuable contributions during the discussion. Let us make the most of this gathering and embrace the opportunity to learn from one another. Once again, a warm welcome to all of you. Thank you for joining us.
Now I kindly request Subhajit sir to extend his warm welcome to Professor Daniel.
So out for some time. Oh, okay, welcome to all. And what happened that CIS Club is our very active club in our NIT, and they used to organize various activity for the student, and they used to organize very regularly about that your technical session, including all the international faculty and from our India also. Okay, so I congratulate all that CIS Club member, and I wish best of luck for them. Thank you.
So fasten your seatbelts for today's seminar promises to a voyage into the heart of engineering excellence. Now I kindly request Professor Daniel to continue with the presentation. Over to you, sir.
Thank you for the kind invitation. Just confirm that you can hear me in good conditions.
Yes, it is fine.
Okay, great. Just also confirm that you can see my screen.
Yes, your screen is visible.
Okay, perfect. So first of all, I'd like to congratulate all of you for this initiative and of course for the opportunity to share this research with you. I will talk briefly about a project an European project we had the possibility to coordinate involving colleagues from Spain and from France on the preventive conservation of cultural heritage buildings. This is a very important topic in Europe, especially in the south of Europe, because we don't have the tradition, the habit of perform preventive conservation. So this is a problem. This is common to many cultures. We build, but then we forget to take care of the buildings on a regular basis, especially for old buildings. Of course, we have to do this, but we can do this in many ways. the idea of this project was to bring the technology, to bring the modern digital tools to this process. But this can be complicated or can be simple. So you have to understand the difficulty or the complexity of problems you have at hand, and then you have to adjust the use of the tools. So this was the challenge we had, and I will talk briefly about this. Okay, well, this is a sentence from a very famous Portuguese architect, really famous, and he realized 20 years ago that people lost the habit of performing maintenance activities on buildings. So normally people do not perform these tasks, and then they will do it only when the buildings are facing huge problems that you need to invest a lot of money. And this is really a big mistake. It's much better to have a preventive activity, a preventive conservation, rather than to do remedial actions that will force you to spend a lot of money. So this is a mistake we perform, and he talked about this 20 years ago. So you can imagine how this is a problem. Well, just to give an idea, I mean, we go to our car to the garage on a regular basis every year or even more, even if the car has no problems. Okay, so you go there and you check that everything okay. Also, I mean, people go to the doctor to check their health, even if they think they are okay. They go to the doctor, but we don't do this preventive activity with our buildings, with our cultural heritage, even with our houses. We don't perform this. We just act when we see a big problem, when we have to face a big problem. And this is wrong. This is wrong from the conceptual point of view, from the economical point of view, from the cultural point of view. This is totally wrong. So we have to change this mentality. This is wrong, especially when you talk about cultural heritage buildings that are with us for centuries. Okay, so we have to change this behavior. So we cannot have a reactive conservation approach that typically we don't have money, or we complain we don't have money, so we don't act, and then when we have big problems, then the money appears and then we do the repair. Or if the money is short, it will be used only for very important buildings, while the other building will not benefit from any kind of activity. While if you do a proactive approach, then you can solve minor problems, really small problems, that will avoid the development of larger problems. So this is the point. This is the goal. Seems quite simple, in fact, but it's still a complex problem. Of course, to do this in an integrated way, you need partners from all the sectors of the society. So you need the owners of the buildings, you need the companies, the private sector, of course, you need the universities and research centers, people that have the knowledge, the technology, so people that know how to decide the best way to proceed. And of course, you need the heritage managers, so the public institutions that are responsible for heritage, because they are very much interested on success of these tools. So you have to put all these players together and define an approach. This was our goal at the beginning of the project. Okay, just to give you an idea, this was a project with Portuguese, Spanish, and French colleagues, and in this area, which is not so big, I mean, compared to India, for sure, it's not so big, but we have thousands of monuments. In this case, just to give an idea, looking at the map, this says we have about 31,000 listed buildings. So a huge heritage that needs to be preserved. And in some areas, you don't have many inhabitants, so they are a bit abandoned, especially low density areas. And this is even a bigger problem, because nobody is there to take care of the building. So this is really a big challenge. And just to give you this idea, we have this problem in south of Europe, and I guess you have also this problem in some parts of India, the need to have a systematic inspection, systematic conservation, looking for minor problems, detect minor problems, and act on a regular basis to avoid larger problems. Okay, so we built a consortium with 8 partners. from different countries at all. So we were the coordinators, and then we work on this project for 3 years. We call it HeritageCare project. So we have to care for heritage. This was the message, and I will show you the main steps of the project. My goal is to inspire you. So you could, if this is a problem for your region, for your country, for your city, I mean, try to develop some kind of research activities that you can go further than we did. So take the good ideas and proceed with them, because this is really an important issue. I just want to mention that we have partners from the different sectors. This is really important. So from the universities, research centers, the heritage managers from the different countries, we have the companies, private companies, and we have the owners of the buildings, like the church. They have a lot of buildings, especially churches, of course, but with problems. And you have to understand that most of these owners do not have technical knowledge. Okay, so for them, the conservation and the preventive conservation and maintenance can be difficult because they don't have the technical knowledge. They don't know what they have to do when they suspect something can be a problem. Sometimes they see a crack. We're talking about masonry building. They see a crack and they think the building will collapse. Of course not. I mean, crack is normal on the masonry, and for them it's really difficult to understand what should be done and when it should be done. So this technical advice is really important. But the universities cannot develop these tools without interacting with the owners, because the owners, they know the problems, but they don't know the solution, but they know the problems. Okay, so this combination of expertise is really necessary. Okay, so if you plan to go for a project like this, you have to bring all the partners to your team. Okay, I will just show briefly the objectives of the project. So in this case, we wanted to create this integrated methodology for preventive conservation. Of course, it's very simple. If you have a building and if you have no technical knowledge, you can ask an engineer or maybe an architect to do an inspection. Of course, they will do an inspection. They will give you a report. Maybe you will not understand the report because you have no technical knowledge. So, and then the report, you will put it there, but after maybe 1 month or after 2 months, you don't know where you put the report because it's paper-based, and this can be a mess. So if you don't understand the report, then you will not pay attention. So you have to be very careful with this. And this should be definitely integrated. You have to bring knowledge from different fields. And of course, I mean, we have quite advanced technologies that should be used, should be considered to improve the quality of these tools. And at the end, you should also define some rules of good practice so people can use it on a daily basis. Okay, so this is really important. These were the goals of this project. Of course, at the end, you have also to communicate to society that if we are researchers, if you are working at university, we have to communicate with the society. Society needs to know what we are doing. We organize workshops and seminars to explain the purpose of our project and to explain them that the things we are doing are important. And also, at the end, we organized a seminar to train professionals on the use of these tools that I will show you. Okay, so you can develop fantastic tools. If nobody understands them and cannot use, they will not be used. Okay, so it's useless. So you need to develop the tools. They should be easy to use, and you should train people to use them. Okay, so you need also to put these things in your project. Okay, how to do this? We established 3 levels regarding the complexity. So you can do many things when you think about preventive conservation. You can say, well, the basic thing is to do an inspection. So you go there, you check point by point, room by room, and then you can just write down a report with a damage survey. Okay, this is nice. It's quite simple, and we do this for several years now. But it's not enough, because if I go there, if I write a report, then if you go there in the following week, you will write a report different from mine, because we will be using different categorization of the damage, and this cannot be done. We have to agree on a damage catalog, a common damage catalog for all inspectors. This was one of the first things we developed in the project, a damage catalog. So everybody, a damage atlas, basically. So everybody would be using, all inspectors from Portugal, Spain, and France will be using the same damage atlas. And the damage atlas should be comprehensive, but at the same time should be simple to be used. Otherwise, I mean, if you go for a very complex one, nobody understands it and nobody will use it. Okay, this is really sounds really reasonable, but it's very difficult to implement. Okay, and once everybody is using the same damage atlas, then you can do the report. But then the report cannot be too technical because the owners will not understand it, will not read it, and it will be a waste of resources. Okay, so from the technical report, you should be able to produce a short, concise report so owners can understand it. Okay, should not be very much technical, should address the most important points on your inspection, but should be clear. Okay, and at the end, of course, you have to provide some recommendations based on your observations. This sounds really simple, but it's not so simple if you have to do this on a let's say on a semi-automatic way. So our goal was to develop this damage catalog. Inspectors, all inspectors, in fact, will be using the same damage catalog. Okay, you are able to produce this information. This information is then uploaded to a web platform, and the platform will automatically generate a technical report and then a non-technical report, a short non-technical report that should be understandable to owners. And of course, after 2 years or 3 years, if you need to go back and perform a new inspection, because this is integrated information, this is based on the platform, you can just access the platform, you can check the previous report, you can produce your new one based on the same damage atlas, and then you can compare the reports from the two different periods. This is really, really important, this comparison. And you know all the time where the information is located, so you can go there and check. The same for the owner. The owner can enter the platform and check the non-technical report. Okay, this is the basic you can do. It's quite simple, cheap, and it works very well. But of course, if you have more complex buildings, you may need to go a bit further. Okay, and of course, you need also to have budget for this. So maybe you need to check your building, but also to check the assets. You have paintings, you have furniture, because it's a palace, imagine, or a museum. So you need to check all these assets. So we produced a damage atlas also for the assets, not only for the building, but for the assets as well. Of course, for this, you need a lot of help from conservators, people that understands about paintings, about tapestry, about furniture, because I'm a structural engineer. I know nothing about these things, but we work together with architects, conservators, so we had a great help. So again, it's very important to have a multidisciplinary team for this. But you need more. Maybe you need also to do some monitoring. Okay, so you need to read some temperature, humidity, luminosity, anything. I mean, the wind velocity, the presence of insects, if any. So you need to know more about your building. Imagine your building, you have a wall that is tilting. You need to check this tilting movement. A crack, a very important crack that is opening, you need to check the evolution of the crack opening and closure. So all these things need to be checked. So you may need to install a monitoring system. Of course, as you can imagine, this requires more expertise, more money. So the complexity is increasing from level 1 to level 2. And in addition, you may need to go for some basic digitalization. You may have some laser scanning and then create a point cloud, or using some photogrammetry to have a point cloud. And in this very basic point cloud, you can have some hotspots, so you can manage the information based on the point cloud. This could be one possibility, or based on your photogrammetric model. Okay, so this is what we have in level 2. But again, if your building is really, really important, and if you have expertise and money for this, you can go for a BIM model that is much more advanced. Is fully digital model where you can basically store any kind of information. You can store the information and manage all the information regarding previous intervention, regarding evolution of some key parameters like temperature, humidity, or others, or correct movement or tilting, anything that you should consider to be relevant in terms of information can be stored in this heritage BIM model. Okay, this is fantastic. This is the ultimate that you can do. Even with this model, you can move into augmented reality, and you can perform the inspection using augmented reality. Okay, but this is quite expensive and requires a lot of expertise. So our goal in this project was to create different levels of complexity, of cost, and of output. And then you have to fit your interest or your budget to one of these, or your needs to one of these three levels. Okay, so you cannot go for the most simplest one or the most complex one. It is not correct from my point of view. So you have to create different possibilities depending on the owner of the building, depending on the needs of the building. Okay, so I will show briefly what we did in each of these three levels. Okay, levels of complexity, levels of work. Okay, so we call it service level because you can see this as a service, basically a service to the society. Okay, so but we have basically these three levels. I will show briefly these three levels. Okay, before that, I just want to comment. Of course, you can do this with a lot of, with a lot of care with your partners, and then you can create fantastic tools. But as I said in the beginning, these tools must work. Okay, how do you know that they work? I mean, you have to test them. And we applied these tools to 60 case studies in Portugal, Spain, and France. Okay, of course, level 1, that is the simplest one, we applied to 60 case studies. And then level 2 to 15, and level 3 to 3 case studies only, because it was quite difficult, quite expensive. So our goal was develop the tool and apply the tool to the case study. This is really important because you can tune this. You can adjust your tool. You can adjust, for instance, damage atlas. You can adjust to work better. So after inspection in 60 different case studies, we know that now it works okay. Okay, so but in the first 5 or the first 10 was not working so well. So we have to be humble and understand that things can be improved, and the best way to improve them is to apply them directly to case studies, different types of case studies. Can be churches in our case, could be palaces, could be bridges. So different types of constructions. And our most important case study was this palace that we have in Guimarães, is nearby the University of Minho. So one of these days, if you come to the University of Minho in Guimarães, for sure you will visit this palace. This is a palace from the 15th century, and we put a lot of equipment here. We did a lot of survey, laser scanning. So this was our case study. It was great because we had a good collaboration with the owners, and we use this as our living lab, basically. Okay, so I will show you now what we did in the different service levels. So different levels of complexity. If you remember, level 1 was the simplest one. So you pay less if you want to think in terms of budget. So the cost is low. You get the essential, basically. Then if you increase the cost, you get more, and then of course you can get the maximum possible with the digital model. But then this is much more expensive, much more complex, and requires technicians with much more knowledge. Okay, so level 1, our goal was in fact to have a very nice inspection report from the building. Okay. The goal was to identify the problems, the cause of the problems, why they are taking place, the cause, and then of course what to do to solve the problem. Okay, so we are really at the upstream part of this process. After this project, so after this inspection, you have an architect, an engineer that will come and perform a design, or then the company, the contractor that will solve the problem. But before all of that, we have to do this inspection, okay? And as I told you before, this is not a common practice in our societies. We don't do this. We ask an engineer to solve the problem. The engineer comes, but is not maybe so familiar with inspection work, so it will be difficult for him to find out the reason of the problem. Okay, so this type of inspections are very useful to track and understand the cause of the problems. Okay, so the goal was then to have a nice report. Okay, of course, for this you need a lot of things. I mean, the equipment. I think I will skip this. I just want to comment that we performed our inspection using a tablet. Okay, so we started the first inspection in 2017, 2018, so six years ago already. But I mean, nowadays everybody has a tablet. Now, in those times, it was not so common, but it was the minimum that you can do. You cannot take a sheet of paper and perform the inspection. This doesn't make any sense nowadays. So that's why I was saying that we have to bring the technology to this. And this is done offline. Okay, you don't have to be online for this. You can in the office you can download all the information you need from the web platform to the tablet, and then in situ in the building you can use the tablet to fill in your inspection sheet form. Okay, so you can fill it, you can take pictures, you can record audios, videos, whatever you think it's necessary. Okay, and everything will be stored in the tablet, and then when you go back to the office, you can upload all this information to the web platform. So all this information will be recorded and it will be associated to the inspection of the buildings. Everything that is information will be there, and you can access anytime. Okay, you can access this anytime. This is the advantage of having everything integrated in a single platform. You can produce also damage maps. This is really important. So you have to define a category of damage categorizations, so everybody can use the same categorization. This is a major issue. I just want to show how we did the inspection. So we start from the top to the bottom and from outside to inside, and we did this in all the 60 buildings. Okay, so we could not forget any point. And then you have, in this case, we define 11 categories, and you have to go one by one in each building and check what you have. So just give you an example. So these 4 groups with the 11 categories, you have to go one by one, okay, and define. For instance, if you go inside to the building, you have to check that is 0.5. In this 0.5, you have to inspect all these subsections. Okay, so this is really important. Of course, there are some areas you may not be able to access, but okay, you have to write this in the report that access was not possible if it is the case. And then you register damage there, okay? And of course, the damage has different levels of importance. So we assigned weighting factors to the severity of the damage. This was very difficult to calibrate, I have to say, because, moisture is one thing. A huge structural crack is another thing, and the importance is totally different. So we established some weighting factors. They are variable values, so you have to adjust from building to building, but it is important to define to state that your damage does have the same importance. Okay, this is really important. Another type that I'm showing, so these were the points that all inspectors had to look at. Okay, this is really important because you have to define this structure. So ideally the report on the damage status should be the same no matter the inspector. Okay, you can send 2 or 3 different inspectors and they should be able to obtain the same result. This is great. Of course, it doesn't happen like this all the times, but this was a major aspect, a major objective. Okay, so to have a report that is independent from the expertise of the inspector. Okay, of course, the inspector needs some training, and it will require a minimum expertise for sure. But different inspectors going on different days, they should be able to obtain the same result. Okay, this is really important. So this is the part of the damage atlas we defined for the building. So we created 7 categories. Then for each category, we defined subcategories, and then sub categories. Okay, and this is really important because this was really a major aspect. I just have to say that if you define just a few categories, then it's too confused. But if you define too many, then you are not able to locate your damage, because it can be in two categories at the same time, and this is not possible. Okay, so it's really difficult to have this very objective. Okay, but anyway, this was our final proposal. Okay, so as I told you, we tested on dozens of buildings. So after all these tests, we end up with this stable categorization. Okay, so you enter the platform, as I told you. So you enter the platform as an inspector. The owners can also enter the platform, but of course the owners will not see the same thing. You as inspector can check all the information. The owners will check only the non-technical information, because they are not able to understand technical information. Okay, so this is the web platform. This is how you see it inside. So this is our tablet. So again, the 11 categories that I mentioned. So you go one by one and room by room. So you fill in all these forms with text, with pictures, and at the end we have a report. So the platform is able to produce automatically a PDF report with technical information and a summary of the inspection with non-technical information. As I said before, typically owners are not able to read or to understand technical information. So how to communicate with them, how to give them the information? We have to use colors. So it's very basic. So you use colors: red, yellow, green, like this. So if they see these colors, they definitely understand the problem. If it is green, for sure they know it's not a problem, it's not a big problem. You have to do a new inspection maybe after 2 years or 3 years. But if it is red, they know that they have a problem. Okay, they know they have to act. Maybe they don't understand totally the problem, but they have to act, and then they will be hiring an engineer to solve the problem. Okay, based on the information they receive from this inspection. Okay, this works very, very well when you have to communicate important, or when you have to communicate technical information to non-technical people. Okay, so this is a problem we don't face at university because everybody understands, but when you are interacting with society, you need to have this care. So at the end you have something like this, okay, with colors, and then we talk about the causes, the consequences, and some recommendations that people can start looking at to solve their problems. Okay, this was really nice. So at the end, basically you have a standardized report. As I said before, if you have two inspectors going there in 2 different moments, they will obtain basically the same result. Okay, and then you create automatically in the platform the non-technical report for the owners, and then the owners have the information to start solving their problems. They have to hire some technical people that will help them to solve the problem. So the goal of the project is not to solve the problem, it's to detect the problem and to understand the causes, and then to alert people for the problem. Okay, but doing this on a regular basis. Okay, level 2, it's for the cases, as I mentioned before, if you have more severe problems, more serious problems, more other needs, and of course you have more budget. So in this case, of course, level 2 takes this inspection from level 1 and adds other layers, additional layers. Okay, so the additional layers can be, for instance, a basic digitalization with, for instance, photogrammetric models with lasers, with laser scanning, and then you obtain a point cloud model. So all this can be produced. You can produce a very basic model. You can use this model to perform some technical tours. You can perform technical tools using this model. This is a castle also we have close by the university, so we did this as an application to a case study. Sorry, I moved it to first. Okay, this was done with laser scanning, so you can create also this model, and then you can create hotspots in these models, and you can navigate virtually through the model and access the information through hotspots instead of entering the platform. So you can have all the information from the report can be put in these basic digital models. Okay, I will show later. If you want to do it in a cheaper way, you can take panoramic pictures, so 360 pictures. Okay, can also be used for this purpose. Another layer that you can add to service 2 is monitoring. Okay, you need some basic information. Imagine about temperature or about humidity or luminosity. This our case study, that is this palace. Part of the palace is a museum, so you need to have this information. It's really critical to have information about luminosity, CO2, some tilting of the walls, all these parameters, physical and of course mechanical parameters, are very important. So we installed several equipment in this palace. This is just the location, the name. So we installed it in different ways, and then you can the point that you can access this information directly on the model, on the digital model. I will show the way we did it, but we did it in a very simple way. So in a way to limit the complexity and to limit the costs. And finally, the last layer is the inspection of the assets. Okay, we're talking about a museum. You have furniture, you have paintings, you have a lot of important things. You have ceramics, so everything that is really, really important. We produced a damage catalog also for these assets. Okay, as I said before, with the help of people that are used to work on this. This is not by engineers. You have conservators and architects and people that care about the assets. But this was also important to perform inspection not only to the building, that was level 1, but now in level 2, also to the assets that most buildings contain. And this is the form for the assets. And in the same way, we produce a report. Okay, the platform produces automatically a report regarding the assets in the same way it was produced for the building itself. Okay, again with colors, of course, but in this case, normally the owner has more knowledge, because I mean he's running a museum. He has some knowledge, not like the ones that have the house and they don't know very well about technical things. Okay, so this is just a picture of what I was in. This is a print screen basically of what I was talking before. So you can have hotspots on your virtual model that will give you access to the information. Can be for the monitoring, or can be also from the inspection report. I will show you here an application we did, so you can see a short video. So this is the palace. So this is a very basic virtual model that we did based on 360 pictures. Okay, so all these are hotspots that give you access to the report. For instance, can give you access to information from the monitoring system. This is access to the report. Okay, but you can also access. I will move this further. Okay, you can. So basically, this is a technical tour into the building, reaching different types of information. So all the information that you collect from the building can be put here, okay, and can be accessed in a very, let's say, easy and cheap way. Of course, with BIM model, you can do much more. You can go much deeper, but then the expertise and the cost is also much higher. Okay. So this is some hotspots regarding the damage we found. Okay, but you see here. So this is a sensor. What you are seeing now, we have a tilt meter on the walls. We have loggers, data loggers for humidity and for temperature. What is important is, again, the owner doesn't. For instance, imagine relative humidity. The owner doesn't care the value of the relative humidity. He just wants to understand if it is okay or not okay. So again, what we did, so you can see here the tilt meter that is measuring the current inclination of the wall. it needs to know if the value is observing is acceptable or not acceptable. Again, we used colors here, okay? You can see colors. For green, it's a range of values that is acceptable. Yellow, it's a range of values that they have to be careful. And then red, so you can see yellow here. Okay, good for temperature, not so good for relative humidity. And red means that it's really in danger. So this is the parameter is too high or is wrong, is not acceptable. It means you have to do something regarding that. So you don't need to have much expertise to be able to understand the information you are looking at. Okay, and this is really important because in practice, this is supposed to be used by the owner, not by us. We are the inspectors, we produce these tools, we'll not be using these tools, okay? So the owner is the person that will be using this. You should be able to understand this information, okay? So you have to combine precise and technical information with the ability of the owner to understand such information. This is really challenging to us. I think you got the idea. So you can, everything that is information, in fact, can be put in this very basic virtual model, okay? Okay, I will move then. So, of course, if you have a very important building, and if you have budget for that, you can go further. Instead of using basic virtualization based on the photogrammetric model or based on the 360 pictures, you can go further. You can perform the laser scanning and you can create a BIM model of your case study, of your building. And of course, if you have a BIM model, everything that is information can be stored and can be managed. So this is in fact the ultimate goal. I mean, we as engineers, this is our ultimate goal. This is really great, but you cannot forget the previous two levels, simplest ones, because they also depend. This also depends on the budget that you have available. Okay, so this is great, but only if you have the budget. That may happen, I don't know, maybe in 10% of the cases. So the remaining 90% you have to use level 1 and level 2. Okay, so they must exist, okay, for those situations, for the majority of situations. Of course, in this level, we just want to say that, okay, if imagine you have this smart glasses with this. This is a bit dated because nowadays you have better tools, of course. But with this, you can perform the inspection. You don't need the tablet anymore. So you can use augmented reality to perform the inspection. This is, of course, this is great, but you can imagine this has a huge cost. It's not possible for all cases. So this is great, but it's not possible for maybe for a few ones. So, but it is also possible to be done, and our goal was to show that this is possible. So first of all, we created the laser scanning, so the point cloud of the building, of our building, and then we created data templates for the structural elements. You have this ready for new constructions, of course, but you don't have for a masonry wall. So create one on purpose for our historical masonry wall. I mean, containing the properties we consider to be relevant. So we have to create all these product data templates on the purpose for the different structural elements. The same for damage. Okay, we don't want to have a very precise representation of damage. Okay, a patch type for us is enough. So we have a patch that says, okay, this is moisture, this is a crack. Okay, so this patch for us is enough. So we also create the data template for this damage. Okay, and then you just attach this patch, and you know in this place you have this damage. Of course, the amount of damage or the area or the length of this is stated in the data template that we produced. Okay, and then you end up with all these elements necessary to model our historical building. And I just want to highlight that historical buildings, they put quite important challenges, because for modern buildings it's really simple. You find most of these structural elements can be found, but for historical buildings you have to create them. Okay, so this is what we did, and then we create the model, and then we start attaching the damage based on the inspection. Okay. As this is just the model, I want to show the work we had to do. Of course, for this you need partners with very high technological skills, because this requires a lot of specific knowledge. I just want to show this video of the work we did with these colleagues from this graphic computation center that was our partner. Okay, so first we did this. Sorry, some of the videos in the Portuguese, but it's not that much important for the understanding. So first we did this on a controlled environment. As you can understand, this is really important that you control the place. So we did this on our office. Okay, we test different things in our office, because the ultimate goal was to perform the inspection using augmented reality. So for that, we don't need the tablet. We can access the damage atlas based on the smart glasses. Okay, so everything could be accessed. We could access the platform through the glasses. So no more the need for the tablets. I'm moving. So you can see the inspection assessing the damage. Okay, in this case is moisture, and attach it to the building. I'll move. So we moved from the office finally to the building. And then we did this on a room, because it was really hard to perform the entire, because we had time constraints. I mean, basically you have a project, you have to run a project, and the project needs to start and needs to finish on time. So we did this on a room, on the big room, just to demonstrate that this technology can in fact be used for inspection of buildings. Okay, quite expensive still, but it is possible. I believe in some years, in the years to come, this will be quite common. So maybe for you, when you become professionals, maybe you'll do this type of inspections. But it's still not that much common. But it is possible. Okay, the goal was to show that this is possible. Well, and to conclude, so we had these three different levels of complexity, of cost, and of expertise that should be selected based on the availability, on the needs from the owner. Okay, so our keywords are diagnosis. So we need to understand what happened in the past. Okay, then we have to monitoring if there is money for this. Of course, this is level 2, to understand what is happening, and eventually to predict what will happen with some prediction models. Okay, and then when you put level 3, then you have management. Okay, so the management will give you the possibility to manage all the information. Okay, so this is really important, because if you want to do management of information, then you need to go for level 3. Okay, that is the introduction of the BIM model. And the final message is, of course, prevention is much better than cure, because prevention, you can act on a regular basis. Your costs are really small compared to a remedial intervention that requires a lot of money, and in some cases it may cause some losses regarding the heritage value, the authenticity and heritage value that we should to avoid at any cost. Okay, we published several papers. I'm just listing here 2 papers that can be of your interest, so they are reachable in the internet. If you have difficulties to find them, please email me, and I'll be very happy to send you these papers in case you are interested in these topics. Okay, thank you so much for your attention and for the opportunity to share with you this research work, and I will be very happy reply to our questions in case you have curiosity or have any doubts. Thank you so much.
It's very quite interesting research work you have carried out. Your team has carried out. Actually, I have some personal queries. Did you basically investigate about that foundation part?
Again,
What
sorry,
is
I could not hear you.
that foundation of that building? Did you
You mean this building in
investigate
our case study?
Yes, in your case studies. In our case, I went to some workshops. So what happened? They investigated the foundation up to 20 meter, 30 meter, like the depth. So they used to see what are the soil conditions there, what are different kind of soil, clay soil, or what we observed that in one of the building they have excavated nearly 20 meter and they put some new soil and stabilize it, and then they have made it long back. They have made it. So did you investigate any of in your research about the soil conditions? Because
No. We had no problems with soil. Normally, the problems we're talking about typically minor problems. In some cases, not so minor because you can have huge cracks. But in our case, we didn't find problems regarding to soil settlements. No.
It may not be because the soil is already stabilized for long back because it is standing for more than 100 years, 200 years. So foundation will not be the major cause to have the crack in the heritage building.
In fact, because typically the cracks the soil settlements will appear in the first 50 or 100 years. And most of our buildings, they have 200, 300 years old. So unless you do some changes on the water table level, then of course, but it was not the case here.
Okay. Another queries I have that you talk about the algae, the biological things that grow on that surface of that heritage building. So what I came across is that if you treat that biological sample with some chemical or if you brush it, then it may take some motor part of that original building, and again algae will regrow. So how basically
you are right. Yeah, you're right. But just to make clear, our goal in this project was not to tell people how they should clean this. Okay. Our goal was to say you have this problem. People for them they were not aware this was a problem. We said this is a problem. It needs to be solved, and then please put this on your list and try to find an expert,
a suitable guy.
Yeah, that will help you solving your problem. But our goal was to be on the upstream part, okay, pointing out the problems. Because the owners that they don't have technical knowledge, they don't know if it is a problem or not most of the time, or they just ignore it. So our goal was to say, okay, we have a structured way to detect problems, to detect the cause of the problems, and to tell you that you have to solve the problems.
Yes. Okay. So, and one more thing, what I observed that in India, recent times, people are using waterproofing paint. You talk about the paint also. What I came to know that waterproofing paint is may not be good for structure health, because once that water enter in that structure, they will not come out.
Yes,
since waterproofing is from inside as well as from outside, so entrapped moisture also will degrade that original structure.
Yeah, I agree with you. Again, this was not again approach in the project, but I agree with you. We had some had some other projects where we did the interventions, and in fact, you need to have the vapor permeability. So everything that you put on the heritage buildings should be permeable to vapor. Okay, not to water, but to vapor, to allow this breathing of the
breathing.
structure.
Yes, breathing of the structure should be there. Otherwise, the waterproofing coating or painting may not be helpful. It will some portion of water will enter but it's not able to escape from that structure. Yes, the ventilation or you can say the breathing should be there. Yes. Okay, and I will allow the student to ask their queries. Okay, actually, but your work is very interesting. Actually, I am working on that project proposal. I'll contact you regarding the budget part. Okay, let me complete it. Then
it will be my pleasure. It will be my pleasure. Thank you.
Aditya, please ask other student to have their queries.
Thank you very much, sir. It's a visionary and insightful session. And now I'll be taking some questions from our viewers. So the first question is from Ayush Kamal. How can professionals and institutions learn and prepare for using this methodology?
Well, it's a good point. This was a big challenge we had because we developed this methodology, as you said. But again, the methodology makes sense if people are aware of it and if they are able to use it. So we created workshops and seminars. So seminars was to make this public. So we want people to know, the municipalities, the public authorities not involved in the project, to know about this. So it was really great because we had this in the 3 countries. People became aware of this. And then we had workshops for 1 week duration to train professionals. So we invite professionals for free and we train them to use the tools. Of course, I mean, 1 week you'll not learn everything, but it was just a demonstration. So inside the project, it was a demonstration. What is really necessary now, of course, we are applying for a new project, the continuation of this work, to go further on this. As you can imagine, a project is funded for a certain period of time, and then when the funds finish, we finish the work, which is a pity. So it's really not so good, but this is the reality of research. So we are looking for a second project to continue with this, to reach more people. But the point, I mean, the answer will be, you need seminars to make people aware of these tools, and then you need training workshops to train professionals to use the tools.
Thank you for answering the question, sir. Now I'll be taking second question from another viewer, Cops. What are the challenges associated with digitalized preventive conservations?
Well, many challenges. In fact, I think the greatest challenge is, I mean, especially for you, that for you young people, you maybe you will be tempted to take all the possibilities of the technology, all the possibilities to this. That will be level 3. This is great, of course. This is fantastic, but it has a cost. It has a very high cost. Okay, in terms of expertise, in terms of equipment. And maybe this will be fantastic, but it not be suitable for most of the end users. So I think what makes sense, bring the technology, bring digitalization, but in the amount that you will need. Okay, not necessarily everything that you have at hand. Don't bring it everything, because then you increase the complexity of the problem. Just bring enough to solve the problem.
Thank you, sir. And the last question will be from my side only, sir. I want to ask a certain question like how much the government or the private entity hire the experts from the renowned universities of a country to check the cultural heritages or any other important structures, how they are doing. Are they doing fine, or there should be some renovation work should be done?
You mean currently?
Yes, sir. Currently means how much the government approaches the universities for such inspections of the structures.
Okay, it depends very much on the country. In fact, I would say in some countries you are lucky enough to have the government interest in the work, so they are promoting joint projects with universities to develop tools. But while in other countries, this let's say public institutes or government institutes, they are a bit limited in terms of budget. In this sense, they will not interact with universities, which is a pity. So it depends very much on the country. My desire is that the public, these public bodies or governmental bodies, they should understand that this is really important and they should invest on it. And the universities are ready to collaborate here in Portugal, in India, I will say in any place. But if they don't understand this is necessary, they will not do the first. They will not come to universities and ask for collaboration. So we have to make them aware that these tools they exist and they are important to preserve their heritage. So this is an effort also from our side to convince them this is very important and useful.
Okay, so, thank you, sir. Now I'll be taking the last question of the session. Can this methodology be implemented in India as well as other South Asian countries?
I hope so. This was the purpose of my presentation, was to convince you that this is a good approach. I would say it's the correct approach, and this can be implemented in the other countries for sure. Maybe we have to perform adjustments to do damage atlas, because your type of damage can be different, of course, based on the climate actions, based on other things. But of course, I mean, the approach, I think the approach is correct. And you know better than me about the need. I guess in most countries, we have this need because people typically don't care about preventive conservation on a regular basis. They don't do it. So if it is the case in India, I'm sure you need it, and I'm sure you can use a similar methodology to solve your problems.
Yes, actually, whatever preventive care in India people are not doing. If some damages occur, then only the government or that private or that organization is to go to some institute. I know one institute, the CBRI, they used to work. But what I observed that their work on the level 1 or level 2. So they used to visit the sites, do some visual inspection, thermographic analysis, BIM modeling, all the things they used to do. But they also started the work, and government also now is taking it seriously to work on this heritage building. And for the same reason, I am also writing proposal so that we can have a center of excellence or some sort of studies we can do here in heritage building.
That's good news.
That's the queries from India's side.
Congratulations, it's a good news.
Aditya, do you have any other query?
No, sir. That's the last question one.
Oliveira, thank you very much for your quite informative presentation.
My pleasure. My pleasure. Okay. Thank you so much.
Sir,
All the best for your initiative.
Sir, as we approach the end of the session, I would like to invite the president of CEST Club, Mr. Satyan Raj, for a vote of thanks.
Our CEST Club is one
very
club.
good evening, everyone. I am Satyan Raj, president of the CEST Club. Would like to extend a heartfelt vote of thanks to Professor Daniel on behalf of the CEST Club for gracing us with his presence and sharing his invaluable insights in this guest lecture for the CIVI-NAR series. Your expertise and knowledge have enriched us, and we are truly grateful for your time and effort. I would also like to express our sincere appreciation to Professor Shubhajit Mandal, the faculty advisor of our club, for his unwavering dedication and support in making this event a reality. Your leadership and commitment have been instrumental in the success of the CIVI-NAR series. Last but not the least, a big thank you to our wonderful audience. Your active participation and enthusiasm have made this event truly engaging and memorable. We hope you found this lecture as enlightening and inspiring as we did. Once again, thank you, Professor Daniel, Professor Subhajit Mandal, and our esteemed audience for making this guest lecture a resounding success. Your presence and contribution are deeply appreciated. Thank you.
Thank
you,
you,
Oliveira.
Bye-bye. Thank you.
I'll email you. Okay, once I
for sure.